So yeah, demystifying Android testing. So basically, there are a lot of myths and a lot of people actually fear to write test. That what I have felt like in my Android developer career. Whenever I bring up, hey, why don't we write test cases? And lot of people fear and move away from them. So that's why we will try to demystify things and let's learn like easy way to write Android tests. A bit about me that already covered by Anupam. So yeah, I am an author, blogger, speaker, GDE for Kotlin and Android architect at Paytm Insider. I also work on the Paytm app or Paytm main app, but yeah. So before diving into testing or writing code on testing, let's learn how many types of tests are there. So there are basically three types of tests. It's very like basic testing pyramid. Uh, there are multiple types of, there are other types of tests, but this is the basic one. So at first there are unit tests. So what are unit tests? Unit test is a common word, but what are they exactly? So whenever say Android and an application has multiple building blocks, right? So if we take each of the blocks as an unit, for example, whenever you are writing an application, you have view model, you have repository, you have probably local data store and remote data store, right? Now, in unit test, we test each of those classes as well as their functions individually. So these functions are small blocks. For example, your repository returns, say, uh, return, if you are building a movie app, right? I'm just taking an example of movie app. If you're building a movie app, your repository will return a movie list, right? There will be a function called return movie list or fetch movie list. So we'll be testing that function without, like, we'll be mocking or faking the dependencies of that function, and then we'll be testing that particular function. So that's called unit test. Now, unit test makes sure that your logic for each particular units or blocks are as correct as it can be. Unit test ensures that. Now, even though if each of the parts are proper or as we want, when we integrate things, things may start to mess up, right? For example, when we integrate local data store and remote data store with repository, we might not get the data as we want them, right? So in probably in repository, we expected that if database is empty, then local data store will emit an error. I am doing that assumption. Database is empty, a local data store will emit an error. And based on that, we wrote the repository code and we tested it that, hey, if local database emits, local data store emits an error, go and fetch from remote data store. Now, on the local data store, when the database is empty, instead of returning or emitting error, we are probably emitting or returning an empty list, right? So when we integrate, while doing unit tests, that will never come up. That, hey, it is like that here and like this there. That will never come up while doing unit test. But if once we integrate and see the product, we'll see, hey, it's not behaving as we want. So there's a way to test. So that is called integration test. We'll integrate repository and local data store and some part of some units together. Will not integrate till the UI or end to end. We'll integrate some of the components together and then we'll test it out and see how it goes. Like if everything behaves as it should. And then comes the end to end test. So that is basically what we do with Espresso. I assume everyone here at some part of their career wrote some of the Espresso test or have at least seen Espresso test. So it is basically writing UI test. Espresso is basically for UI test cases, but with Espresso, what we do is that we pass all of the dependencies along with it, right? We don't mock, generally we don't, except from the API with mock web server, we don't mock other things. So with Espresso, all the dependencies are properly tested. Everything is integrated, and we just test the whole flow. Hey, on clicking of this button, this movie list should load, and everything. That is called end-to-end test. So yeah, we'll start from unit test, and then we'll slowly try a little bit of integration test, and then we'll, if time permits, we'll try out some Espresso as well. Now, today I actually don't have a project ready because I wanted to do everything here live. So everyone can see Android Studio, right? I have probably stopped the sharing. Everyone can see Android Studio, right?
Yeah, we can.
Okay, so we'll go ahead and create a new project. We'll go for some basic activity. Let's go ahead with it. Kotlin, yeah. Wait a moment. It's not the preview version. Okay. Yeah. So we don't have the Jetpack Compose. So if things don't work out, I do have a have something that's already running. I will explain with it. But yeah, I am hoping to do everything live.
You're a brave man, Rivu.
Yeah, I have a backup plan. That's what I'm saying. Oh, shit. Uh, so it as it turns out that Android Studio has stopped working. So this is not anyone's fault. It's basically Android Studio doesn't like on in Big Sur. If you run Android Studio in full screen, it behaves like that. So we just created a project. I want to open that only. My application 2, I guess. Yeah, it's no longer full screen, so everything will work out fine. So in Big Sur, in Android Studio, whenever a dialog comes, Android Studio freezes. It's a frustrating issue, but it's there. That is still running. Yeah. So let's wait for indexing to complete it. Okay. Another thing is that I don't have a emulator, but I have a real device that I will show here. So I'm running this application. Where is Android Studio? Yeah. Where is my device? Yeah, here it is. So once it runs, you will see it come here. So instead of emulator, we'll be using this device today. Yeah, now while it's running, let's get on the business and write some code. So what we'll be building today is basically movies list app. I have something like that already in GitHub. I will show it here. The Jetpack Compose MVI demo. If you look at it, I have used Jetpack Compose to build it. And don't be like, don't fear the name MVI. It's nothing. Yeah, it's just MVVM with a unidirectional flow. It's nothing to be feared of. So here you can actually see the test cases and all. Yeah, test factory. And so here I have test cases for remote data store. Here I have test cases for local data store. Here I have test cases for the repository. And here I have test cases for the view model. Right. And if you go to Android test, here I have the unit test cases. I am not using Espresso here because here I have used Jetpack Compose. But yeah, you can find the unit test cases, UI test cases here. So yeah, another thing to note here is that this test is not end-to-end test. Here I am just testing the UI. Why? Because here everything is not integrated. I am just passing different states here and testing the UI behaves properly. But with Espresso, we don't just pass state directly to the UI. We emulate the whole flow, the repositories, database, and everything is actually generated. So with Espresso, end-to-end test cases is possible. I will show today. So yeah, here you, as you can see, previous next, this demo code has run already. So yeah, so we'll replace all of them basically. So yeah, let's start with the data, basically with the model, what we want to show. So to make things actually a bit quicker. I will copy few things from here, especially the data class. Data. So yeah. So yeah, basically there will be a list of movies, and this is the ID of the movie. This is the poster, basically URL. This is the title, type here. List of movies will be there. Now, we have the data class, right? Now let's write down the local data store. For example, let's first start with the local data store. Here I am, for the sake of simplicity, I am writing everything on one package only, inside one package. But this is in my opinion, this is the best practice for packaging. So here, if you can see here, we have the base package for all the base classes. Then we have a feature package based on the feature. For example, movie search feature is here. And inside movie search, there is data again that contains the repository, remote repository here. Then data store interface, then local data store, and remote data store. So yeah, in my opinion, this is the best packaging structure you should follow. But yeah, let's continue. Today we'll have everything in a single place. So let's first name the first create the data store interface. So, or probably better movie data store. It will be an interface. So interface movie data store. So what should a data store do basically? So a data store should have a function that should return the data. Get movies list that will return list of what's happening. Movie, and data store should also have a function that will save the movies, right? Now, another thing to note here is that ideally, when you are dealing with remote data store or local data store in the implementation, you will not get them instantly, right? So if you are using RX, it should be a single, and this should be a completable. And if you are coroutine, if you are using coroutine, then both of them should be a suspend function. So let's go get ahead with coroutine only. So I will add the coroutine dependency. Where is the GitHub? This should have the dependency. Yeah. Model. So yeah, it is done. So let's make both of them suspend function, and we are done. Now, let's create the implementation. So let's start with local. So here, ideally, you would this would have a dependency on database. If you are using Room, you will have Room database dependency here. If you are using something else, you will have that here. But today, again, to keep things simple, I will just have the implementation here. I will take a empty list as constructor parameter with default value. I will consider this as DB. List of, yeah, I will consider this as DB. And here, this should ideally return. And save movie should actually table. Yeah. So local Datastore implementation is done, right? Now, let's write test for this. So I'm creating a new test. Obviously, we'll be using JUnit 4. Nothing else to do here. You can actually select these functions if you want. Okay, here it should be actually private. Yeah. You can actually select these methods if you want, but it's not required. You will write them down anyway. So here you will select the folder. So we are not writing the instrumentation test. If you are writing instrumented test, then we'll select the Android test folder. But since we are writing unit test cases, we'll select the test folder. Now our empty test class is here. How to actually clear up these annotations? Clear. Yeah. Now I am no longer annotating. Yeah. So in order to check that our test class is running fine, I will write a hello world test case. And here I will basically just assert equals hello world, and I will run this test. So it is just a simple function with at the test annotation that marks this function as a test function basically. And yeah, little green tick here. So this means that it's running perfectly. Now let's write down the actual test cases. So what do we have here? We want to test this one, right? So we'll need an instance of local movie data store. So we have one letter into var. Now, what does it have as a dependency? So generally, we'll have a room DB here, and we'll mock it here. But today we don't have that room DB. Mocking I will come at later. Let's see something with something like, let's see our test with something easy. So instead of mock, we have an empty list, right? So file list is equal to mutable. It will be mutable list. Sorry. Yeah, done. Now we have a setup function, right? Where I will actually create instance of the Datastore implementation. So here we'll create a function with at that before annotation. So this is basically, this will run before every test. If you see here, this function is basically used for setting up things. So here it actually tells how it is run. So it will run, it basically runs before every each of the tests that you write. Now here we'll create instance of this implementation. So basically this equals to this. Now we'll pass this movie list instance here, and we are done setting up. Now let's add some data here, right? So where do we get the data? So in order to generate the data, we generally create a data factory or test factory, however you call it. So it's generally an object or test data factory. Like many people call it different way. I call it test factory sometimes. Sometimes I also call it data factory. So basically, there should be a function get stub. So this is basically stubbing. Now, what is stubbing? Stubbing is creating a list of items. Basically, it's for data classes that you use in your test cases. It's creating a list of items at the runtime while the test is running. This is basically a fake list of items. This is called stubbing. Okay. There are multiple ways to do it. You can generate a loop, and you can run exact set of numbers, like exact 10 items each time you call this function. You can also randomize these things, right? So for example, let me do it. Uh, so it's basically a random number I'm generating, and then we'll create a movie instance where ID will be this random number that we created. Now it is string, so we can just do this and then poster title, type, and year. So we can put whatever we want. Basically, poster is ideally supposed to be a URL, so we can put something as slash poster slash num dot jpg. This will actually not link to anything, but yeah. Again, this is stubbing. They will not actually show anything, right? And then what we have, title, type, year. Okay. Now type, we can put movie only, and then here we can actually get 19 and then dollar random. Yeah. So this will be 2 digits only, max to max. So if it is 1 digit, then this movie is released far back in human history. That movies actually started getting created. So yeah, this would be fun. Now we have the stubbing ready, right? So first thing is that fastest we'll write is that whenever we call get movies, it should return some data. So test get movies should return data. Now, so first thing we'll do is that if movie list already consists something, we'll clear the tab. Then we'll put movie list dot add all. Here we'll call test factory dot get stub movie list, and then we'll call the function that will return the movie list, right? So yeah, before that we need a run blocking. Yeah, I will do that. We'll just use this instance. So we'll actually need to collect the data. Data is equal to dot get movies. Now it will show error because we are not using it in a coroutine. So we can just use a run blocking here. Sorry. Yeah. Now we'll assert that. So assert first takes the expected value and then the actual value. So expected value is obviously this movie list, and exact value is that this returned data, right? So return data should be exactly same as the movie list. That's we need to test. So let's run this and see what happens. Yeah. Okay. Yeah. Really sorry. So basically the stubbing we need to put the return statement. So we can run the same test function. Yeah, it runs perfectly, right? So that's about unit testing. Now, let us quickly implement the not remote data store, repository, right? So we'll talk about mocking there. Uh, so this is the local data store. Let us now create a repository. So I'm not creating the interface any longer. Now we should create. We are running out of time. So there's the repository. It has dependency of local data store. I'm writing local DS and movie data store, and it should also have dependency on remote data store based on your business requirement, basically. So what should this do? This should actually have a function. Again, it should again be suspect function uh, where you will call fetch movies, and this should return list of, or rather you can, instead of suspend function, you can also use flowable. But yeah, let's stick with suspend function only. So if what it should do, it should first check the local DS. If local DS dot get movies, if it is not empty, if this is not empty, this should return this local movies, right? Else, if it is empty, it should actually call the remote. So remote ds dot get movies, remote movies. Now again, if remote movies is not empty, it should actually save it to the local, uh, local ds dot save movies, and then it should return it Otherwise, it should throw an exception. So and remove yes empty. Yeah, this is how it should work, right? Now again, let's write unit test for this one. I'm here setting up the before writing the setup function. Again in test folder, not in Android test folder. Now again, what do we have? We have repository, this movie repository, and movie repository has two dependencies over movie data store. So we need to have local DS as well as remote DS in order to create movie repository, right? Now how do we get them? I haven't even created remote data store implementation, right? So how do I get them? So that's when mocking or faking comes. So there are two options. One is we'll create a fake implementation of these classes, right? Another thing is we'll use something like Mockito. Sorry, Mockito. So there are multiple options. There is Mockito and there is Mock-K as well as Mockito. There is Mock-K. Sorry. Yeah, this specifically for Kotlin. We can use either of them. So today I will show you Mock-K only. It's both are basically simple enough and same basically. So we'll copy this, and in the release section we can see the version. Issues, where are the releases? Yeah, release 1.10.6. So in Gradle I will add that as a test implementation. 1.10.6, 1.10.6. Now let's sync 1.10.6. Yeah. So here you can actually check the dependency declaration. Yeah, implementation Mock-K 1.10.6. 1.10. This should actually work. Now let's get back to repository test. Here we'll use Mock-K dot okay. So we use these annotations. They will basically generate the implementation before you use it. So here to sorry, repository. Here we'll first pass local DS and then remote DS. Now, back to our first test. So first test will check what happens if local DS returns data, right? Fun should return data from local DS. So first, so whenever this local DS yeah, so here you can actually see the syntax. So yeah, we injected like this, and so whenever on every call of local DS dot get movies, okay, wait, it should be co every. So here I am using this syntax. This on every call, this returns this, right? So whenever this is called, it should return. It should return. We don't want a empty list, right? So let's create a stop data here. Test factory dot get stub movie list, return stub data, right? Now if we call movies repository dot fetch movies, again it should be inside a run blocking. Then I will assert again expected data is the stub data, and actual data is the returned data. So if local data store returns something, it should never even check the remote data store. It should return this data exactly, right? Now let's run it to find out what's going on. If it behaves properly as expected. No, it failed. Local DS is not initialized. Okay, I have probably missed something. Mock annotation is there. So do we, okay, yeah, mock annotations dot init. So dot init, this should do it. Mm. Something is going on. Okay. Okay, Android we don't need because we are not following Android. We are not going to do Android instrumentation testing. So yeah. This, yes. If this doesn't work, we'll go forward with Mockito. Yeah, it works perfectly fine. So yeah, I missed passing the object. Earlier Mockito also had these kind of things, but now Mockito have removed them. Mockito still has like you need to pass the instance. So yeah, if now moving on to our next test, that if uh, local DS returns empty data, you should call remote DS, right? So should call remote DS. Now every time local DS is called, we should return empty list. And every time remote DS is called, we should return the stub data. Now we'll check which one we get. We should get the stub data, not the empty list. Now we can run the class directly so that both the test cases will run. Okay, this one didn't get properly. So yeah, we didn't mock. So when save data is called, save data is not implemented, right? So it actually failed the test cases because we haven't implemented that save data. So whenever, local ds dot save movies is called, now here we can pass any list, or and it should actually do it. So let's run it. Okay, save movies, any. Okay, so any list should be there. Or rather we can pass the stub data directly here. Okay. I think I missed returns unit 1. Yeah. Now both of them runs perfectly, and we get the that repository works. Now, instead of creating a mock here, we can actually pass the local DS instance to check that, hey, when integrated, this works fine. Local movies, Datastore IMPL. And now we can, basically, I can copy this movie list from here to here. And I can pass it here. And again, just like what we did there. So instead of this, we can just do list dot clear list dot add all stub data. Now, ideally, it should return the data from the movie list. And here, instead of this, we are just calling movie list dot clear. So this should actually test the integration between local data store and repository. We can't do it for remote data store because I don't have actual implementation for remote data store. Yeah, it runs. So here we are stubbing the dependency of local data store, but we are passing the actual implementation of local data store to the movie repository, and we are mocking the remote data stream dependency for the movie repository. And yeah, we are writing test cases. So yeah, I don't think we have time for a bit of espresso test. So I will like to wrap it up here. And yeah, if you have any questions, you can ask them now. Any questions so far?
People feel free to ask question, else you can add them on Slido also.
I can actually open the chat section if you're asking.
Hi, Rivu.
Yeah, hi.
This will say. So I have a question regarding the compose thing. Is that okay if I ask it now?
Sure.
Sure. So no, they told me compose is specifically, I mean, not specifically, it works well with MVI, right? So that's what.
Yeah, it works well with MVI. It works well with a lot of other data structure and a lot of other architecture patterns as well. Compose is not dependent on your architecture pattern, to be honest.
Okay.
Yeah, you need to have a proper architecture to actually pass the latest state on the compose. So compose works better if you have a state-based architecture. For example, if you are using a view state with MVVM, that should work perfectly fine.
Okay.
And that should actually make it easy for you to jump to compose.
Okay. So I've been using Spotify's Mobius. So
Mobius is perfect. Mobius is functional architecture basically. So if you're using Mobius, then it's perfect. There's no issue. There should not be any issue with compose.
So that's what I want to ask. Is there any need to switch to Mobius to MVI? So that's
see. I haven't used Mobius and compose together. Now Mobius is a kind of library, right?
Mm-hmm.
And compose is still not production ready. To be honest, it's still in beta.
Mm-hmm.
So I'm not sure if there is some issues regarding it, like those plugin might have some other complications when used together, right?
Yes.
I'm not sure about that because I haven't used, but ideally Mobius should work perfectly fine with compose.
Okay, great. Okay. So that's what I wanted to ask your opinion about it.
Yeah.
Thanks.
Cool. Any more question regarding what we did today?
So we have a couple of questions at
Sure.
the Slido link. First one is, any particular reason we are using JUnit 4 instead of JUnit 5? That is one.
Yeah, sure. I would like to clarify. So JUnit 5 is actually fascinating, to be honest. And I have used JUnit 5 along with Spec. I am a huge, like, I am a fan of Spec, which actually lets you write testing as a DSL. I have an example. I should have an example on the shared project only. So here, if you see the test cases, this should be Spec. Yeah, they are Spec. So as you can see here, this is JUnit 5 with Spec, and JUnit 5 gives us this freedom to do it like that. Now, JUnit 5 is not like, and Android is a bit backdated, I would say. Android is not very much compatible with JUnit 5. So in order to use JUnit 5, you need to do a little bit of setup. Gradually you need to add a couple of things in order to work with JUnit 5. So today I wanted to avoid them. That's why I used JUnit 4, which is easy to set up. Basically, it doesn't need any setup. If you create an Android Studio, JUnit 4 comes attached with it.
Okay. Next one we have Rivu is Chetan is asking, what is your opinion on KO test?
KO test I haven't used. I basically like Spec a lot, so I haven't used KO test. So, and basically for normal testing, I think JUnit does perfectly fine job. So I can't share my opinion about KO test because I haven't used.
Fair enough. Next one you have is, how do you manage test as part of the production code base? Any strategy to make it easy?
Yeah, so basically this is the most important question, I would say. So whenever we write something new, right? We write test cases for it. As you saw, I didn't went like when I wrote the local data store, I wrote that local data store test first. I didn't went on adding the repository and then writing the test cases for all of it. So whenever we write some blocks, we write the test for it. And I generally prefer following TDD, which is nothing but just whenever you create the interface and create a implementation of it with the to do, with everything to do, write the test and then write the implementation. So I try to follow that with production code. So yeah, it basically bundled together along with your production code writing. So there's like, you don't have to do like, if you follow like this, you write the whole code and then you write test case, then you will never find time to write the test case. If you follow like this, hey, I wrote this function, let's write test cases for this function, then you will always find time. I hope I have answered.
Chetan, do you have a follow-up there? No? In that case, we
yeah,
have one more.
I'm here. Sorry. So yeah, like what you've said, I completely agree on that. But also the thing is that whenever we are facing with the production code, we are changing it regularly, right? So all those changes also lead to the change in the test cases.
Yeah.
Even if you just consider the fact that if there is a data class, I remove that field and shift it to some other place, I have to also migrate out all that tests regarding that field to other place, right? So it becomes kind of a bulky, messed up kind of task, it's no longer an easy thing to do. So you have any strategy that can, easily help us out to?
I would like to share. So here, what we did is actually a wrong practice. We have only one data class that is used between data layer, production, presentation layer, like that is used in the data store, that is used in the repository, and that will be used in the view model. That is actually a bad practice. So what we do is that for data store layers, we have a separate data class, and we have a mapper that actually maps the both data store layer data class with presentation layer data class. So actually it becomes easier. So if you change something on the presentation layer, but didn't change something on the data layer. You don't need to change something on the data layer. So while modifying test cases, you don't need to touch the data layer test cases. You just modify the test cases that are on presentation layer. That depends on that class. So it becomes easier. Also, we have integrated testing, like we are using CI/CD. So basically, whenever someone raises a peer, all the test case results are shown. So if someone by chance missed some test cases, modifying some test cases, it will show on the peer. So that person can easily go and update the test case.
Okay, separation. So separation of concern is the key.
Separation of concerns is a big thing.
Okay, got it.
Yeah.
There's a question on UI test. How do you maintain UI test like TDD you mentioned? An example for UI test would also be good.
Yeah. So I guess you are asking about end-to-end test. So I actually had planned to show the example today, but today we don't have much time. So let us try something. I should have here. Wait a moment. I will go to my repositories. This one is Jetpack Compose. This one is again Jetpack Compose, Jetpack Compose. This GitHub repositories. This one should not be Jetpack Compose. Let me see. SRC, Android test, projects. Yeah, here. So this is the activity rule. Here we are testing the function. So whenever activity launches, the shimmer view should show, right? And then we are using mock web server. So that is actually, instead of making actual API request. So I'm not sure if you guys are familiar with it or not, but in Firebase you can actually upload an APK and they run a lot of UI tests, right? If you actually do API request, your server might get down because of it, because of the whole lot of requests. So actually we are using mock web server. So sorry. It will return dummy result. Yeah, this one that I have it here as a JSON instead of actual making API request. So whenever this result comes, I am checking this is shown in the view. Now what happens is that so retrofit actually makes the request. Just instead of it reaching out to our API, it reaches to this mock web server, which is set up internally in the Android app only. And after that, there is a remote data store involved that actually returns the data to the repository, and then repository returns this data to the view model, and then view model passes this data onto the view. So whenever I am checking that, hey, this item should be visible, right? This item is displayed. I am checking this one is displayed or not. I am checking our item is displayed or list is displayed. It actually checks end to end. It checks from the view till the retrofit actually. So yeah, this is how end to end. This is actually end to end test.
Hi, I also want to ask that how do you repeat this? Like, UI test actually, end-to-end test actually like changes the thinking. Like suppose UI changes, so that's also a thing.
I could not hear it. Was your voice was breaking.
Yeah, I'm Rohan, I'll ask the question and you have typed, right? I'll ask the same.
Yeah.
There's a little bit on noise on your end. So Rohan has a question which says, um, Rohan has the same question. Let's take one from Manoj. Rohan, you can type your question in the chat. Your voice is breaking a little. Related to architecture, you use case between repos and view model. How do you make sure a particular project copes with all the new architecture patterns? It's a general question in general, no, not related to this.
Yeah. So basically, when working on the Android project, right? So these all the architecture example that you see, it's generic. So and this is not actual architecture. This is actually architecture pattern. Now, when we work on the real projects, depending on the project need, what we do is we actually create a custom architecture, right? That actually fits our requirements. So it's very seldom we actually copy the generic architecture pattern example and use it in our code. We do copy it, we do follow the generic ones, but we do some of the modifications that depending on the project. So yeah, that's how generally it goes with every company, I guess. Like in my past experiences, I have done that only. I followed something that is generic. Probably it's created by me or someone else, and then I did the modifications to fit the custom requirements.
People feel free to ask the question related to the topic or in general Android related GAN that you want that Rivu to share light on.
So if you Manoj here, just adding to like what I've asked. So just wanted to know your thought process about use cases and repos. Like, do you see any difference in them? And if yes, then how do you differentiate?
So if you're asking about use cases, so use cases has like there is a difference between repositories and use cases. And actually I have heard some people's opinion that repositories kind of start becoming a masterclass that handles it all. So that's why use case comes in. So here we have only one function repository, right? While writing this example, but it's never that the case. Like that's never the case in our actual project. In an actual project, there are multiple scenarios, and depending on them, there are multiple functions on repository, and probably there are multiple data stores as well. Right. Now, use case actually defines like for one particular use case. Say you have to load fast load. So for fast load, there is one use case, and that will deal with that use case will have data regarding, hey, this is the first time load, load from the local data store and remote data store, whatever. This is for the first time load. And then your screen, for some other scenario, there should be another use case. So it's further dividing out the, like instead of having everything, all the scenarios together in the repository, you're dividing it on the scenarios, or rather on the use cases itself. But I personally try not to use use case because that actually bloats the classes a lot. So I personally have direct repository only.
But then it contradicts your idea of like repository would become a God class down the line.
Yeah, that actually becomes sometimes. But it's generally, like as I said, it depends on the project. So I generally like don't have use case. Like if in this project as well, in the example as well, you will not find use case. I use use case if I see in a particular page there are too much of scenarios that you need to handle. In that case, I prefer use case. Otherwise, if I see it on the requirement basis. If I see there is a requirement on the use case, there are multiple scenarios that needs to be handled, and repository is becoming God class, having that much of logic, and testing it becomes difficult with that much of logic, then I start dividing everything on the use case. Otherwise, I generally go with repository only.
So you end up writing, like, let's assume if there are some business logic so end of the day we should, how do you think it should be written in repository or?
Again, as I said, depends on the requirement. So if you have one or two scenarios only, and repository interface consists of 3 to 4 functions, there's no use for use case, right? If your repository interface consists, say, 20 functions, interface itself, I'm not talking about the implementation. If there are 20 functions on the interface, you should consider use case.
Okay. But
so that will actually reduce the functions on the repository.
Okay. So, but then in general, if you see, as project evolves, we might end up being in a situation where a repository ends up in in that state where we have the number of functions are increasing. So do you think we should plan accordingly or?
Yeah. So if you are aware that the particular repository I am writing for, going forward, it might have multiple, like lot of dependencies, lot of other scenarios and all. You can go ahead and write with use case from the beginning, or otherwise use case is generally easy to plug in, right? So while you are ad hoc adding new functions, instead of adding new functions, you can add one use case as a dependency to repository for a new scenario. The repository in that way will become a mixed kind of thing, but that you can take it up as a tech debt. We can't have everything optimized from the day one, right?
Correct. Yeah. True. Okay.
We have one more for you, Rivu, from
sure.
Robin. So Robin is asking, can you please tell me what is the benefit of the interface pattern? I mean, why we have movies repo interface and movies repo IMPL class instead of directly having movie repos class?
Yeah, there's nothing wrong with having direct movies repo class, right? For example, today I did just that. I didn't have the repo interface. I directly wrote the class. Now, while you are passing that to the view model, you can have the class and pass it to view model, and but testing it, like mocking the repository, when you need to mock the repository, it's always better to have the interface. You can always mock the actual classes implementations with if your class is open, but that has its own certain complexities. So it's always, for mocking purposes and for testing purposes, it's always better to have interfaces. And also, if you have interfaces, it's easier to plan. Like so in the interface, you can see like if you need to find a function which does something on a certain scenario, you can always look at the interface to find that out, right? And parameter and return time and everything. If you in the implementation, it's always like most of the time it's a lot bigger, the implementation process. So it's always better to have the interface. Mostly for testing, I would say. It makes mocking easier.
Cool, guys. If you have more questions, feel free to ask them just by turning on, unmuting yourself and directly asking Rivu.
Cool.
Robin, Angad, Hitanshu, if you have any question, feel free to ask them. No. In that case, we'll just bid adieu to Rivu. Rivu, thanks for taking out the time. It was an absolute pleasure to have you and explain the nuances of testing by actually daring to code it live and actually doing it also. So that is unique, and that is you're a brave man, Rivu. So that's about it. Thanks, Rivu, once again.